Today we have problem 6 from the Harvard MIT math tournament, where we're given that Kelvin is a frog that starts at 0, 0 and wishes to reach 3, or 0, 0, 0 and wishes to reach the point 333. And in a single move, he can either increase any single coordinate by 1 or decrease his z coordinate by 1. And so given that he can't visit any point twice, and he must stay between 0 and 3 at all times, we want to find the number of distinct paths that Kelvin can take to reach 333. And so you can sort of think of, Kelvin moving around as just on a cube, a 3 by 3 cube. Like this. Oops. And he has to, I guess, he starts here, right? Let's call this 0, 0, 0. And he has to move all the way to this opposite corner. And he can only move right along these lattice points. And I guess lattice points inside the cube as well that I can't really draw. And let's call it this direction x, this direction y, and you can only move in those two directions, but in the z direction you can move both up and down. Alright, and so let's sort of view this as levels, or you can't really see the inside of the cube. So the only way we can sort of see it is to view it as levels based off of z. So if you can imagine sort of like looking down from the top, then we have when z is equal to 0, our board is just a 3 by 3 board. And this will be the same for all other levels as well. Right. And we have this is z is equal to 1, z is equal to 2, z is equal to 3. And our start point will be at z is equal to 0 in this corner, and our end point will be z is equal to 3 in this corner. And so viewing it in this way, you see that we can only move sort of this way. Within each board, we can only move sort of rightwards, upwards, or I guess between each board, we can go in any direction, because that's just increasing or decreasing z by 1. And so the other condition we have is we can't visit any point twice. And so what will we, get in trouble with that condition? Well, because we can only move in the x and y direction in like the positive direction. So right, that's like moving this way and this way. We can't really, I guess, move leftwards or downwards. So what that means is, if we just focus on the x direction, we'll go in this way. Let's say we move right twice. We can't ever go back because that's not a legal move. So that means we won't ever visit we don't ever have to worry about visiting a already seen position if we move in the x direction, because we can only move forward and not backwards. And similarly in the y direction as well, right? Because we can only move upwards, every time we do move upwards, it'll be, a new y coordinate that we've just never seen before. So we won't ever, have to worry about visiting a new state when moving in the y direction. So the only issue we have is, I guess, in the z direction then, because we can move, both forwards and backwards, right? So imagine if we, let's say, go right once and then upwards once, and then let's say we increase z by 1, so we go to this point here. Then we can't really go back again, right? Otherwise, we will visit this point for the second time. And then let's say we move, I guess, upwards from this position, and then let's say we increase z by 1 again, right? So we go to z is equal to 2 at this position, but again, we can't decrease z to go back to this position. And so I guess moving in the z direction will be the only issue we'll ever have in regards to, I guess, visiting any point twice. So let's just ignore it for now, right? And so if we only move in the x and y direction, then we can really just focus on one of these boards, right? And the analogous, problem would just be if we start from this green point, then we want to just finish at the opposite corner at this yellow point. And so how many ways are there to do that? Well, we have to do 3 moves rightwards somewhere in our walk, right? And then we have to do 3 moves upwards somewhere in our walk. And those are actually the only moves we will make because we can't move backwards. Right, so we can just view it as, say, x is moving rightwards, y is moving upwards. Then the number of walks to get from the green point to the yellow point is just the number of ways to order the string, right? Because any ordering, let's say y, y, x, x, y, x, will correspond to a walk like upwards, upwards, or upwards, upwards, rightwards, rightwards, upwards, rightwards, right? And so the total number of orderings for this is just 6 choose 3. Okay, and now given this, let's add back in, our z moves. And let's choose a random ordering of this. Let's say x, y, x, x, y, y. Then our first move will be in the x direction. So we'll be here, or whoops. And so now we have like a choice to make any z moves, right? And in this case, we can either do nothing in terms of z, or we can, increase z by 1, make 1 move in the z direction, make 2 moves in the z direction, or make 3 moves in the z direction, right? Any of these are possible. And so really there are 4 choices to make here, right? And let's say we choose like to increase it twice. Right, we'll increase z twice there, or I'll write that again. Right, we made 1 move in the x direction, and now we made 2 moves in the z direction. Okay, then we make 1 move in the y direction, so we go upwards once. Then what can we do now in terms of z? Well, again, we can do nothing. We can increase z by 1 to get to here. But remember, we can also decrease z, right? So we can either decrease it by 1 to get to z is equal to 1, or decrease it twice to get back to z is equal to 0. And so again, we have 4 options of what to do in terms of z. And so let's say we just decrease it by 1 this time. So we get to here. And now we move in the x direction, right, as z is equal to 1. Or this should be, let's mark this as z prime to denote it as, subtracting 1 to z. And now we are at this point. And you can see we're just at the same, after every x or y move, we have the same option for z, right? And the decreasing or increasing z doesn't really matter because we can just think of it as we can just choose which level we want to be on after every x or y move. And there are 4 levels, so we just have 4 choices each time. And so for any given sequence, again, let's say x, y, x, x, y, y, after every move, right here, we can view moving in the z direction as just choosing which layer we want to be on. And there's 4 choices here, 4 choices here, 4 choices here, 4 choices here, 4 choices here. But we have to be careful as in the after the last move, we have to end at the red point, right, at 333. So we're sort of forced to move just in one direction, right? Let's say we end up at continuing our walk. Let's say we just don't make any more z moves anymore. So we're at this point. After our last move, we have to move twice in the upwards direction to finish at the red point. So there's only one option in this case. But note that we can also choose which layer to start at before we even make a move. Right, when we start at the green point, we can also choose which layer to go to before we make any x or y moves. So there are also 4 options here. And so in total, that means for given any sequence of x and y's, we have 4 to the 6th possible options for z before or after every single move. And so we multiply that by 4 to the 6th, and to get our answer of 81,920. And that's it.